3.5, Solving Systems with Technology. So we've already solved these kind of systems before. Basically, we're looking for two lines where they cross, but we're going to use Desmos today. So if you can get to the calculator and go to the menu and go to Desmos, you know how to get to Desmos. So we've got two equations, negative 10x plus 8y equals negative 22. So we can see it's just a line. And then 6x minus 8y equals 10. Okay, so two lines. And, we've just got two lines. We look at where they cross. Looks like they cross at 3, 1. That's your solution. So what I want to do here is let's just show it like this. We've got lines that cross like this at 3, 1. Okay. So then the next one, hopefully you can tell there's going to be a line and a parabola. But still, let's go to Desmos and we can do it quickly. Y equals x plus 2 and y equals x squared minus 4. So here we see there are going to be two solutions, two places where the lines cross, and it looks like it would be negative 2, 0 and 3, 5. Two different solutions, negative 2, 0 and 3, 5. So again, I've got a line and a parabola. That's terrible. And those intersection points were negative 2, 0. My stylus isn't working very well. And 3, 5. All right, next one. I can see an upside down parabola and a V shape. Y equals negative x squared plus 8. Y equals, and I think you can do ABS. If you type in ABS of x, yeah, that'll work. Or the vertical bar is way over above the enter button. I think that will work as well, the vertical bars. Okay. Interesting looking shape there. Parabola and absolute value there. So negative 3, negative 1, and positive 3, negative 1. Just go ahead and draw it out. Just give me a little sketch. It was negative 3, negative 1, and positive 3, negative 1. All right, number 7, you may not recognize what these shapes are, okay? But that's okay. It doesn't really matter because we can let Desmos do the work. So this first equation, 2x, and the caret is shift 6. So shift 6 puts me up into the exponent for a square, plus y, shift 6, plus 10x minus y plus 6 equals 0. Interesting. It appears to be either a circle or an oval shape. Yeah, it looks like an oval shape. And this next one, negative 2x plus y minus 1 equals 0. Okay, oval shape and a line. Looks like maybe they only touch in this one point right here. Do they touch? Hard to grab it there, but it looks like they touch right there. There we go. -1, -1. Okay. So I've got an oval, and this line just barely touches that one place. -1, -1. Now, number 9 is where it starts getting different. Okay, this is going to be kind of weird because you should notice you see a third variable. Desmos isn't going to handle a third variable because what we have is 3 variables, 3 dimensions. We've got a 3-dimensional graph, 3-dimensional shape, whatever this is, and we've never graphed those before. So I'm going to show you something new. If you go back to your to Goldadder and notice the second thing on there is Geogebra 3D calculator. I'm going to show you how to graph something in 3 dimensions. It's going to be kind of cool. We'll see. Okay. So first thing I want to do is get rid of this shadow, this plane. So if I go here, I'm going to click that and it just turns it off. So what you see is 3 axes. There's an X and a Y and a Z axis, puts us in 3 dimensions. So it works similar to Desmos. You've got your equation input over here. So the first one I'm going to type in y equals -2x plus 3z plus 21. And, yeah, I wasn't quite on the page because of the scale. But it's on there. Notice I can kind of spin it around and stuff. There we go. If you spin it around, you can kind of tell what it is. It looks like it's a plane is what it is. Okay, it's this 2-dimensional surface. So that's what it looks like when you graph in 3 dimensions. Let's try the next one. X equals 4 is a second plane. And so you can see those 2 planes, if you rotate it around here, those 2 planes intersect. And they actually intersect in a line, if you can tell. Okay, not a point, but in a line. So let's look at the third one. Third one, -2y plus z equals -1. So we've got these 3 planes, and it's kind of hard to tell. Let me zoom this up a little bit. It's kind of hard to tell what happens. So I'm going to click this, and I'm going to change its color. Let's change this one to red, and let's change this one to, I don't know, green. Okay, maybe we'll be able to see better here. But if you look, it's kind of weird because instead of intersecting lines, we have intersecting planes. That's because we're in 3 dimensions. So I guess your job would be to find where those 3 planes intersect. So it looks like right here there would be a point. And it's very, very difficult on this thing to see where they cross. There's a point right here. It's really hard for me to tell what their intersection point is. Now, there's a process to go through and see that, but I'm going to show you a different way to find that intersection, which is much easier, I think, than this. All right. So it is kind of cool to see what it looks like when you graph a 3-dimensional figure like this. But I'm going to use a different tool to find this intersection. Now, the hard thing is there's some setup. In order to use this next tool, all of our equations have to be in standard form. And so standard form looks like, ax plus b y plus c times z equals plain old number. So in other words, all of my variables have to be on the left side, and all my plain old numbers have to be on the right side. That's how this is going to work. So, excuse me, what I'm going to do here, and at some point I hope you'd be able to do this in your head, but I'm going to add the 2x to get it to the left side. And I'm going to subtract the 3z to get it on the left side. And so I cancel this one out, I cancel this one out. I'm going to end up having 2x plus the y that's already there minus 3z equals 21. Okay. And then my second equation is already set up. It's kind of weird, but you've got x, and then you've got 0y and 0z equals 4. And then the third one, you don't have any x, so you've got 0x minus 2y plus 1z equals -1. Now also that x right there, we could call that 1x if we want. So that's the setup that we will need for this site. We need it in standard form. We get it in standard form, it's going to be easy. So if you go back to your sites list, your math sites, and you scroll down to the one that says Gauss-Jordan Elimination. Okay, that's the one we need, Gauss-Jordan Elimination. Okay, so we want to create a matrix, and we want a 3 by 4. If you go back and look, okay, hang on. If you go back and look, what that means is there's 1, 2, 3 equations, but there's 1, 2, 3, 4 numbers in each equation. All right, so we want this to look like a 3 by 4 matrix. Okay, so create that 3 by 4 matrix. And I don't know why it defaults to these numbers, but we don't want them. So hit clear. And we're going to enter in all those numbers that we had. So let's see here. Okay. So 2, and I like to hit tab, and it goes over. Y there is 1y, -3z, and 21. Just keep hitting tab, it goes to the next spot. 1x for the second equation, 0y, 0z equals 4. And in the bottom, 0x, -2y, 1z equals -1. Okay. Now, once we've got all those numbers in, you're going to hit solve. Okay, I hit enter, but that hits solve. Okay. Hit solve, and it does all this messed up looking stuff. And we don't really need to know these steps. That's for a different lesson, I suppose. But you scroll down here to the bottom, and once you see this last matrix here, if you read it, remember this first number was the x number, then the y number, then the z number. What this says is 1x equals 4. And this next one says y equals -2. And this next one says z equals -5. And so we can see our answer here is going to be 4, -2, -5. That's the answer. 4, -2, -5. So you can either write x equals 4, y equals -2, and z equals -5 like that, or you can write an ordered triple. Notice it's not an ordered pair. There are 3 numbers here. You can write it like that. Okay, now we're rolling. So number 11, this one's going to be a lot easier because it's almost completely set up. The only thing missing is the 0y on the second one. But otherwise, it's already in standard form. So we can go back to our Gauss-Jordan, and let's clear. Okay, and let's get that over here. All right. So we've got -4 and -3, -2 equals -14. We've got -3x, 0y, 3z equals -6, -2x, 3y, -1 for the z equals -25. Solve. So again, We just have to scroll down to the bottom, and the very last one tells me x equals 5, y equals -4, and z equals 3. 5, -4, and 3. Simple. So 13, again, 13 is pretty much all set. Let's see what's missing. 0y down here at the bottom. I can't get it. 0y. Okay. Clear. So the top equation says 24x, 8y, 49z, negative 133, negative 18x, 1y, negative 43z, 262, 4x, 0y, 6z, and negative 90. Solve. Really complicated until you get down to the bottom. X equals negative 39, y equals 33, and z equals 11. And that was negative 39, y was 33, and z was 11. Okay, now don't forget, don't forget what we're doing. We're finding x, y, and z. So then number 15, it's the exact same thing, so I don't really need to show you it again, but I'm going to just for the sake of finishing it out. Okay, so clear, and this time it's giving me a video, so let's, I don't know, I can't move my screen up this time, but whatever. Negative 38, 26, 16, 312, negative 38. Oh, notice the variables are different, r, s, and t this time, but it doesn't really matter as long as you keep them in the same order. We've got r, we've got s, we've got t, so negative 30s, 5t, negative 456, 6r, 8s, negative 4t, 240. Notice I'm not entering the variables. Okay, we hit solve. I don't know why I'm having a hard time scrolling here. There we go. Okay. Negative 8, 20, negative 32. Negative 8, 20, negative 32. And don't forget what we're finding. We're finding R, S, and T.